Hello everyone, I'm Typhoon, and in this lecture, you will learn about filters in Wireshark. Filters in Wireshark help you control which packets you see during analysis. A filter is simply a rule or condition that defines what packets should be shown or hidden. If there's a traffic you don't need, you can filter it out. If you only want to focus on a specific traffic, you can create filters to display just that. Wireshark offers two main types of filters. The one is capture filter you see when you start the Wireshark. Capture filters, these are applied before packet capture begins. They control what data Wireshark captures in the first place, filtering out unwanted traffic right from the start. And we also have the display filters. These are used after data is captured. They'll help you sift through the captured packets, showing only the data that meets your criteria. Capture filters are useful when dealing with large amounts of network traffic. They help reduce the workload on your system by only capturing relevant packets. This improves performance, especially during long capture sessions. How to apply a capture filter? Open Wireshark and click on the capture options. Next, the interface you want to monitor, in this case ENS33. Locate the interface you want to use, as I did here, and in here, labeled capture filter for selected interfaces, click on the empty field. For example, to capture only traffic on port 80, type port 80. And here we are. If the text box turns green, the filter is valid. If it turns red, there's an error in your expression. And then click Start to begin capturing packets. You will now see only the traffic related to port 80. So, you may ask here, why use capture filters? The first is efficiency. It reduces the amount of data captured, saving memory and processing power. And it also helps with focus. It allows you to hone in on specific issues without digging through unrelated packets. So, Wireshark uses Berkeley packet filter, BPF syntax for capture filters. This syntax is also used in tools like TCP dump, making it widely recognized in networking. A filter expression consists of primitives, which are simple building blocks made up of qualifiers define what to filter, like host, port, net, so on and so forth, and number or name, the specific address, network, or the port number you are targeting. You can capture the traffic to a specific IP, like, let's actually get our IP address. DST host this. Oops. And here we are. We capture packets from this IP address, and we also do like that. Or like DST host and port 80. That's it. Enter. Refresh the page that uses HTTP. And here we are. We are capturing packets sent to this IP address that are using port 80. So remember, if you know a little bit of programming, you are familiar with this logical expressions or logical operators. Let's open the notepad. Here. And means this here. Double ands. It means if both conditions must be true, or here means this double pipe, at least one condition must be true in this case. And we also have not. In with not excludes traffic that matches the condition. So we can do some expression like that. For example, filters in Wireshark are powerful tools that allow you to isolate specific packets for analysis. A common use case involves focusing on traffic related to particular network devices. Depending on the scenario, you can filter packets based on device's MAC address, IP version 4 address, IP version 6 address, or even its DNS hostname. When you're interested in the traffic of a specific host interacting with a server on your network, you can apply a filter using this host qualifier to capture all traffic associated with that host's IP version 4 address. And here we are. This filter captures both incoming and outgoing traffic related to this specified IP address. And if you are working with IP version 6 network, the approach remains the same. You are going to use host qualifier with the IP version 6 address, for example, like this. When IP addresses are dynamic or frequently changing, filtering by MAC address is effective. Combine the Ether protocol qualifier with the host qualifier, like Ether, host, and your MAC address. And click Enter. This captures traffic associated with a specified MAC address. To refine your filters, you can specify the direction of traffic. For example, let's get the IP address, IP version 4 address here, put it here, and src host. In this case, this filter captures only traffic originating from host. And we also have destination filter, DST host and IP address. And this filter here captures only traffic destined for a host. Here we are. So, if you omit the type qualifier, for example, host, net, or port, Wireshark assumes host by default. For example, DST is equivalent to DST host IP address. So in most cases, you can also not just ignore the host. Filtering by ports is particularly useful when focusing on specific services or applications. To capture a traffic to or from a specific port, you can write port and port number. Press enter, and here we are. And you can also exclude port traffic by adding this asterisk operator before port. So this operator, as I said, excludes traffic that matches the condition. And you can also do DST port 80. You can combine port filters with direction qualifiers. And this is useful for monitoring HTTP traffic directed at a web server. As I said, the capture and display filter syntax are the same. So we will start with zero capture filter. And let's set ICMP to wait for ICMP traffic. This is useful for analyzing ping requests and responses. You can also exclude, let's actually write this like that. You can also exclude TCP traffic like this, and here we are. TCP protocol are gone. Or you can do the same to the UDP. And here UDP is gone. This negation operator or asterisk ensures that all traffic except UDP is displayed. By mastering these filters, you can streamline packet analysis, focusing only on the data that matters the most in your network investigations. To summarize, you can filter packets based on specific bytes in the header, such as ICMP 0 or ICMP 0, like this, for ICMP types. And you can extend your filters to multiple bytes, like 0, 2. Or let's actually write TCP02. For TCP flags, you can filter by individual bits using this AND operator. For example, TCP 13 and 4 equals 4. And here we are. These advanced filters are incredibly useful for capturing the exact traffic you are interested in without sifting through unrelated packets. They give you fine control over which packets Wireshark will display, making network analysis more efficient and targeted.